this is a probability lesson. In this lesson, we are going to be creating sample spaces. Sample spaces are a set of all possible outcomes in a situation, a probability situation. They can either be a list or they can be displayed in a tree diagram. The easiest way to deal with these is by just showing you examples of different probability situations. All right, first, we're going to create these sample spaces. All right, flipping a quarter. Think about a quarter. You have heads or tails. That's the only two things that can happen. So if you flip it, it'll either land on heads or it'll land on tails. So there's only two possible outcomes. So there's your list of your sample space. All right, what if we flip a quarter 2 times? So our first time is we have heads and we have tails. Those are our first action. That's what can happen. So if we landed on heads, for our second action, we could land on heads or tails. And then if we landed on tails the first time, we could also land on heads or tails. And so what you do is you count the second numbers. And so there's 4 possible outcomes if you flip a quarter 2 times. All right, what if we flip a quarter and roll a 6-sided number cube? Just a standard 6-sided cube. All right, so our first action would be getting heads and our tails. And then if we landed on heads, then we could either roll a 1 through 6. And the same thing would happen with tails. If we landed on tails first and then we rolled the dice or the number cube, we would land a 1 or all the way through a 6. And so when you count the second row, there are 12 possible outcomes. And that as a list would be heads 1, heads 2, we could get heads 3, and so forth. Same thing with tails. Tails 1 all the way down through tails 6. To me, a tree diagram is a little more organized, and then you don't mix up what you're trying to do, and then it's easier to count. All right. All right, what if we flip a quarter 3 times? All right, so our first action would be heads or tails again. Our second would be heads or tails both times. And then our third would be heads or tails each of those. And again, you count the last row. Our list, if you count the last row, it would be 8 possible outcomes. And our list would be heads, heads, heads. Then our next one would be, go back, heads, heads, tails, heads, tails, heads, and it just keeps going through. And so you just have to work through the list. Again, that's why I like tree diagrams. Again, it's just whatever you're comfortable with. There's still 8 different possible things that could happen. All right, Witten went clothes shopping. He bought 3 pants, 5 shirts, and 2 pairs of shoes. How many outfits can he make? All right, whenever I have a situation like this that I deal with, I don't want to deal with the lower numbers first. I want to deal with the higher number because you're going to repeatedly use those second actions and third action. So I'm going to deal with the shirts. So I'm going to lay out all 5 shirts. There's the 5 shirts. He can pick any of those 5. Then he has 3 pair of pants. So each shirt can go with all 3 pairs of pants. So then you end up with all of the pants. Okay? Now think about writing this down and how long that would take. I just used some clip art from the public domain, so I appreciate them sharing the clip art with me. All right, then now he's got 2 pairs of shoes. So each pair of pants is going to have 2 different pairs of shoes that he could possibly deal with or choose from. That's a lot of different outfits. So then, because our shoes was our last action, our last deal, we would count them. And so if you count, there's 6 in each set, So there are 30 different possible outfits that he could have. All right. Now, creating this size of a sample space took a little time. I mean, I had to set those up. It didn't seem like it with me clicking through over them already done, but it does take it. So is there a faster way? There is. And let me show you that faster way. If you don't need to know exactly what is happening with your sample space, each different individual thing, and you just need the number of how many things that could possibly happen, this is what you do. You multiply the possible outcomes of each action. And let me show you how that works. All right, when we had the quarter and the number cube, then we would have 2 possible outcomes with the quarter, and then 6 possible outcomes with the number cube. And so we ended up with 2 times 6, which is 12. For flipping the quarter 3 times, we have heads the first time, heads or tails. The second action is still 2, and the third action is still 2. And so we end up with 8. And if you multiply 2 times 2, you get 4 times 2, and you get 8. So there's 8 possible outcomes. On our clothes shopping with our Witten, if we took our shirts, we would have 5 shirts, our pants, 3 possible, and our shoes, 2 possible. So when you multiply 5 times 3 times 2, you get 30. And so again, if you don't need a list of everything and you just need the number, that's the easier way to do it. And this is called the fundamental counting principle. And what that just says is exactly what I just told you. You multiply the outcomes of each action, and you get the number of possible outcomes in that situation. As always, thanks for watching, and you can always email me with questions or comments at bethemath@gmail.com.